Hello everyone, welcome to my channel. In this video I am going to explain active low pass filter and active high pass filter experiments. For this let us start with the low pass filter. Aim of this experiment is to study the frequency response of first order low pass filter. Apparatus required for this experiment are first order low pass filter trainer kit. This is the trainer kit. Function generator, CRO, and digital multimeter and connecting patch cords. And coming to the experiment, first thing is we have to set the input 1 volt at 1 kilohertz using function generator. This is the function generator. Here you can see the knobs 10, 100, 1K. By keeping 1K and keeping the fine frequency knob maximum, you can set 1 kilohertz frequency in function generator. Make sure this attenuation dB knob has to be released, and positive terminal is connected to channel 1 probe CRO and negative like black terminal is connected to black. And you can see here the signal input signal. This is the Y position of the input signal. You can see here by adjusting the amplitude knob. By adjusting the amplitude knob there, you can keep it exactly, it should fit in one box. So number of divisions here on y-axis 1 into this multiplication factor. So 1 into 1 volt. Input signal is set. Now we have to set here the resistance value here. The reason for setting is, let us see the design of active low pass filter. If R value and C value are known, then FH can be written as 1 by 2 pi RC. Where R value we have substituted 10 kilo ohm and C value we have substituted 0.01 microfarad. By substituting these values, we will get FH equal to 1.59 kilohertz. Suppose if FH is known, C is known, we can find the value of R. Here FH and C are known, we will assume that, and we will change here the value to 10 kilohertz. 10 kilo ohms. This is the potentiometer which ranges from 0 to 22 kilo ohm. So we have connected the probes of multimeter, and you have to keep here volt, and this is common, and keep this pointer towards the resistance values and adjust potentiometer and check the resistance value to be 10 kilo ohms exactly, 10 point something, 10. Okay, you have to do this adjustment before switching on the kit. You have to off the kit and make this adjustment, then remove it. Do not disturb the potentiometer value, and now make the connections. Input signal to be given for this kit. Input signal has to be given like this, red to red, black to black, and output is observed at CRO channel 2. These are the connections to be done. So we are giving input signal through function generator, output signal we are observing in channel 2 CRO. Switch on the kit, observe the output. So the top one is input signal and bottom one is output signal. Just read the value now. It will be around 2 volts. Number of divisions, Y divisions 1, 2. 2 into multiplication factor 1. So 2 volts. Output we are getting 2 volts. If you calculate the gain, you can write G equal to 2 divided by 1, but here it is 1.8. Let it be. Earlier we got 1.8, so we kept it as 1.8. V naught divided by V. So now we have to see the frequency response of this low pass filter. You have to change the frequencies from 50 hertz to 1 megahertz. So if you want to keep the frequency as 150 hertz, you have to change corresponding time period knob and observe the readings. This has to be continued, and note down the values of V naught for all the frequencies for 50, 70, 100, 300, 500, so on. You have to note down all readings using calculator. You have to just calculate these two columns, and using graph you have to draw the graph like this. and draw a 3 dB line at the highest value minus 3 dB, and this draw a horizontal line. It will intersect this curve at one point. That point you drop that to the horizontal line, and this value is nothing but the cutoff frequency. Here for practical values we got 1.7 kilohertz. Theoretically we got the value 1.59 kilohertz. So both are near values. This is how we will perform active low pass filter experiment. Let us move on to active high pass filter. Switch off the kit. Again, even for this we go with the design part. If you can fix FH value, FH is 1.59, FL value 1.59, R value 1 divided by 2 pi into C value we know it's 0.01. So here you have potentiometer again. It varies from 0 to 22 kilo ohm, and keep the value 10 kilo ohm by using this potentiometer. You can see the reading in multimeter. Switch off the kit and you have to set this value. After setting the value, remove the probes and keep the input signal. Make the connections. Again, input you have to give like this. Input you are seeing in channel 1 and output will be seen in channel 2. Only 4 wires are needed for this connections, input to output. And switch on the kit and again keep at 1 kilohertz and observe the signal. Observe the output. You can see here output 1.4, here 1 into 2 more divisions, 1.2, 1.4. So you are getting output as 1.4. Then again take the response, start from 50 Hz to 1 megahertz and note down the values of V0 in CRO channel 2, and using calculator calculate these two columns and then draw the graph and identify the peak value and draw minus 3 dB line. This minus 3 dB line intersects the curve at one point, and that intersection point you identify it on X scale. That point is nothing but your cutoff frequency, which must be very near to theoretical value. So theoretically you got 1.59 and practically you are getting 1.4 kilohertz. This is how we can perform active high pass filter experiment. Thank you.